Welcome to my channel. In this video, we are going to be taking a look at the force experience between charges. So we take a look at a typical example. So we have, what is the total force exerted by Q1 and Q2 on Q3? And the diagram is given by this. So from there, we notice that we have three charges, Q1, Q2, Q3. Q1 is a positive charge, Q2 is a negative charge, Q3 is a positive charge. So we are asked to find the force exerted on by Q1 on Q3, Q2 on Q3. So if you take a look at this diagram, you notice that the force between this one is attractive, while the force between this and this is repulsive. So we can imagine that this particular charge and this one are fixed, while this one is can move easily. So what we notice is that the force between this and this, which is attractive, will make this one pull towards this. So which is this force, F2 on F3. And the force between this and this will make this one move away from it, which is F1 on F3. So what we want to find is F2 and F1 on 3. And as a result, we'll now find the resultant by finding the difference between these two forces. So first of all, we need to know the force between two charges, which is given as F equal to K, Q1, Q2. Our K here is a constant. R here is the distance between the two charges. So we have to find F2 on 3, we have F2 on 3 equal to Q2 times Q3. We take the magnitude, which means even if our Q2 is positive or negative, we just take the positive of it and go ahead and calculate our F. Okay, so what's our Q2 and what's our Q3? Which is 1.5 and 5. So we have our K here is 9 times 10 raised by 9 Newton meter squared per coulomb squared. Then we have our Q2, which is 1.5 nano. Our nano here means 10 raised by 9 minus 9. Our Q3 is 5 times 10 raised by minus 9 coulomb all over 0.4 meter squared, which is the distance between them. Okay, so when you resolve this one using your calculator, you get 421 times 10 raised by minus 9 Newton. So we also apply the same approach for F1 on 3, and we get this, and this. We can see that the distance between charge 1 and 3 is 1. If you go back to the diagram, the distance between them is 1 meters. So our final result for F1 on 3 is 162 times 10 raised by minus 9 Newton. Now we notice that F1 on 3 and F2 on 3, they are in opposite direction. So we'll take the difference. And we have, we're supposed to have F2 on 3 minus F2 1 on 3. And our result is 259 times 10 raised by minus 9 Newton. At this point, we can rearrange our answer by taking 10 raised by minus 3 out, multiply with this, and we will left with 10 raised by minus 6. And that 10 raised by minus 6 will give us micro. And we have approximately 0.26 micronewton. That's the resultant force. And because it is positive, it means that the force, the resultant force, is moving upward, not downward. It's moving upward. Okay, let's take a look at another problem, and we have, what are the magnitude and direction of the net force exerted by Q1 and Q2 on Q3? So this is the diagram that we have. We have our Q1, we have our Q2, Q3. So these two charges are acting on this particular, they're exerting a force on this particular. So we have to find the force, resultant force on this particular charge. Now, first of all, to solve this problem, we have here to be 0.4 meters, 0.3 meters. We can infer from Pythagoras theorem that from here to here is 0.5 meters. Now, the force between this and this is repulsive, so this one will move in this direction. So we also imagine that these two, they are fixed. So this one can easily move. So the force between this and this will move this charge in this direction. And the force between this and this will move this one in this direction. So we have, then the angle between this, we can call it theta. And the angle therefore between this and this will also be theta. And this one will also be theta. So we have this. So the angle between this part and this part will be 2 theta. So let's start with the force between two charges. We have F equal to Q1, Q2 all over this. So the force between 1 and 3 or 2 and 3 is giving us 1 and 3 is given by this expression where our Q1 is 2 micro. Our micro is 10 raised power minus 6. Then Q3 is 4 times 10 raised power minus 6 all over 0.5 meters. That's the distance between them. So F1 on 3 is finally giving us 0.29 Newton if you use your calculator to compute. Now if you notice that Q2 on 3 will also have the same force because the charges are the same and the distance are the same. So we have F2 on 3 is equal to this expression, and finally we still have 0.29 Newton. Right? So to calculate the resultant force between this and this, it's important for us to know this angle theta. And our angle theta here is determined from opposite all over hypotenuse. Arc theta is equal to arc sine opposite all over hypotenuse, which is 0.3 all over 0.5 or 3 all over 5. So we have arc sine 3 all over 5, which is giving us 36.87. So our theta here is 36.87. Our theta here is also 36.87. So the angle between this force F2 on 3 and force F1 on 3 will be 2 times this one, because this angle here is theta, this angle here is theta. So the angle between these two forces will be 2 times this. So to find the resultant, we use this expression Fr equal to square root of fx squared plus fy squared. So we need to find fx squared, fy squared, and insert them here to get this one. So our fx squared, to find our fx squared, we first of all assume that this force is lying on the zero axis. So that if it is lying on the zero axis, the angle between this and this will be 2 times this. So we have this first force, which is 0.29 times cos 0 plus this one 0.29 cos 2 times this, which is 73.74, and that gives us 0.3712 Newton. So to get our Fy, we just replace our cos with sine, and that gives us Fy equal to 0.29 sine 0 plus 0.29 sine 73.74 equal to this. Right? That's the easiest way. What we'll do is assume that this one is lying on the zero axis. So if it is 0, it takes this one. Then the distance from here to the angle from here to here is 2 times of this, and that will give us the other parts. Okay, so we can slot this one into this expression, and we have this expression Fr equal to 0.46 Newton. So that's the resultant force. So in what direction? So we can use our theta equal to arctan this part all over this part, and that gives us 36.8 degrees. And what you notice is that this 36.8 degrees is exactly equal to the angle we computed for each of those forces, so which is half of the angle, right? So what that means is that the resultant force from this one is pointing in this direction. And the question we want to solve is given as, what is the magnitude of the net force exacted by Q2, Q3, Q4 on Q1? So the diagram that we are going to be considering is given below. So we're asked to find the force of Q2 on Q1, force Q3 on Q1, force Q4 on Q1. And they are all positioned at the corners of a square of length L, right? So the force experienced by this on this is giving us, although we can also note that from here, the length from here to here is given by using Pythagoras theorem, square root of 2 times L. So we have it as L square root of 2. Then the force experienced by this on this is giving us, because we assume that this, and this, they are all fixed, and this one can easily move. So when this one and this interact, because of the equal charges, this one will tend to repel this one. So in this direction, for this and this, it goes in this direction. So we have it in this form. So the force experienced on this one by this particular one is also going to be in this direction. So we're asked to find the forces acting on the resultant force for this system. So in so doing, we have the force for two equal charges, or for two charges, is given by F equal to K, Q1, Q2 all over R squared, right? So the force between Q1 and Q2 will be given us as the force on 2, or the force of 2 on charge 1 is given by this, where you have your Q squared, L squared, then multiplied by K. Then we also have the second one, which is Q3 on 1, right? It's given by this, and we can see the length is different from this particular one. So the length is L root 2. So if we square this one, it becomes 2L squared. So that's why we have this. Then finally, we have Q4 on Q1, which is giving us KQ squared all over L squared. So we notice that this force and this force are exactly the same, except this one. So at this point, the next thing we should do is to find the resultant. And to find the resultant, we must first of all know that all these forces, right, we can resolve them along the x-axis and along the y-axis, and as a result, find the resultants using this formula, right? So at this point, let's find our fx. To find our fx, take note, we assume that this particular force is pointing at an angle of 90 degrees from this point. So if this one is 90, and remember that this one is 45, angle 45. So here to this point will be 90 plus 45, which will give us 135. Then from here to here will give us 180. So in so doing, we have our F2 on 1, this 2 on 1, right, is 180. F3 on 1 is 135. F4 on 1 is 90, right? So at this point, we can resolve this one by finding cos 90, cos 35 using our calculator. Then we'll have this expression. So we can see that cos 90 is 0, right? While this cos 135 is minus root 2 over 2, cos 180 is minus 1, so we have this. Now, remember our F2 on 1, this one means F2 on 1 is KQ squared all over L squared. F3 on 1 is KQ squared all over 2L squared. And by the time we plug them in, we have this expression. So what you notice is that KQ squared all over L squared is common. So we can easily factorize, and we get Fx equal to minus KQ squared all over L squared 1 plus square root of 2 all over 4. Now we can call this term T and call this one R, and we can say it's minus TR, right? So that whenever we need it, we can bring them in as T equal to this part and R equal to this part. So let's take a look at our f of y. We have it as Fy equal to F21 sine 180. All we just need to do is to replace our cos with sine, and we simplify and it reduces to this point. We can see that our sine 90 is 1, sine 135 is root 2 over 2, sine 180 is 0. So we have this. Now if we recall our expression for F31 and F41, we have Fy equal to square root of 2, this and this. And what is common? We have KQ squared L squared into brackets 1, because here will remain 1, here will become 2 times 2, 4, then root 2. Now remember that we said this part is T, this part is R. So our Fy will be TR. So if we substitute into the original expression, which is the formula for the resultant force, we have our Fr equal to this part, which is the x part, this part, which is the y part, right? And we simplify. We have 2 of tr squared. Now, this square will take care of this root will take care of this squared, and this root will come over this 2, and we have Fr equal to square root of 2tr. Now, at this point, what is our t? Our t is this part. What is our r? Our r is this part, and we have Fr equal to kq squared L squared root 2 plus 1 over 2. And that's it. I hope this helps. Please like, share, and subscribe for more. Thank you.